Hello, folks. Uh, today I will talk about combining functions. Combining functions for the level College Algebra. So you may think of this combining functions like combining numbers at the beginning level. What type of operations, like arithmetic operations, we have for numbers? We have addition, we have subtraction, we have multiplication, and we have division. So this is going to be the same format for the first four operations. Like for example, just I can go over this on an example. Now consider this one. Let's say f of x equals to 3x plus 5, and let's say g of x equals to x minus 2. So let's say for example you want to find f plus g of 2. So this is same as finding f of 2 plus g of 2. Just add the values. So if you plug in 2 in f, you will get 3 times 2 plus 5, which is 6 times 6 plus 5, that's 11. So I have 11 plus, if you find g of 2, that's going to be 2 minus 2, which is 0. So it's going to be plus 0, and that's going to be the sum of those two, which is 11. So that's how you find the sum. So let's say for example you want to find f minus g of, let's say, 0. So that's going to be f of 0 minus g of 0, which is f of 0 is, you see, 5. F of 0 is 5. It's 3 times 0 plus 5, which is 5, minus g of 0 is 0 minus 2, which is negative 2. Be careful, that's negative. Negative will make it positive, so that difference will be simply 7. So this is how you find addition, subtraction. Division and multiplication and division works in a similar manner, but I want to show you when you have the actual function combination. Like for example, let's say you want to combine, now that's another example. Let's say you have f of x equals, let's take the same values, same functions, 3x plus 5, and g of x equals to x minus 2. For example, what is f minus g of x this time with the variable? So it's similar. This is going to be f of x minus g of x, and you will combine like terms. Like you have 3x plus 5 minus, for g of x you got x minus 2. You can distribute that negative to both terms, and we have 3x plus 5 minus x plus 2. So now combine similar terms. It's going to be 3x and negative x. It's going to be 2x. Then you have 5 and 2, so it's plus 7. So that's how you find the difference of two functions. Now let's take a look at some, like maybe I can do a little bit more when you have, for example, what about f over g of x? Because that division, you should be careful. It's going to be 3x plus 5, that was the function, divided by x minus 2. So you see, when you write down this, you have to just make sure that x is different than 2, because that's not in the domain. Because of the division, the number 2 will be excluded from the domain. So if somebody, for example, asks you what is f over g of 2, this is simply undefined. It does not exist. Or if you, let's say you want to find fg of x, that's going to be the product, so it's going to be 3x plus 5 multiplied by x minus 2. So you can use a FOIL. multiply the first terms, multiply the outer terms, then you multiply the inner terms, and then the last term. So we got 3x squared from the first terms, and then you have minus 6x, then plus 5x from inner terms, and then minus 10. So you can combine these two, so that's going to be 3x squared minus x minus 10. So this is how you do algebraic multiplication, division, addition, subtraction. And we have one more actually really important operation that I'll cover. Now that new operation is actually what we call composition. I can just write that down here. It's the composition of two functions. Composition. It's defined in, first, like, let's do a motivation example. So, for example, let's assume that g of x is given by 2x squared minus 4. So for example, if you want to find g of a, that's going to be 2a squared minus 4. X replaced by a. If you want to find g of, for example, star, that's going to be 2 times star squared minus 4. If you want to find g of, for example, bucks, let's say you insert bucks into g, that's going to be 2 times bucks squared minus 4. That's kind of like, you see, whatever you put inside, that changes with the bucks. Like, for example, let's say you want to find g of x to the third. That x to the third goes into the bucks, so it's going to be 2 times x to the third squared minus 4, which is going to be 2 times x to the 6 minus 4. So that's going to be like an important tool in composition of functions. So let's just define the composition. So the composition of f and g is defined by, we just write it with the circle, f circle g of x, which means in f you insert the function g. So you replace x by g of x. So like, for example, in the functional value, let's say you have f of x equals to, let's say f of x equals to 2x plus 4, and let's say g of x equals to square root of x minus 5. Now let's say you want to find f composed with g of, let's say, 9. So that means you're looking at f of g of 9. So first, as you can see, you need to find the inner value here, g of 9, that's going to be square root of 9 minus 5, which is square root of 4, which is 2. So that means I'm looking at f of 2, because inside the parentheses you got g of 9, which is 2. So I plug in 2 in f, so it's going to be 2 times 2 plus 4, which is 8. That's how you find the functional values. But be careful, the other way around will not be the same. Let's just check that one. For example, let's find, for this example, let's find g composed with f of 9. So that was this is g of f of 9. So I need to find f of 9 first, which is 2 times 9 plus 4, which is, you see, 18 plus 4, 22. So I'm looking at g of 22. And g of 22 is square root of 22 minus 5, which is, as you see, square root of 17. So, which actually shows that the order is really important in these compositions. Order is very important. Now we can further go through this same example with the composition in general, like what is f composed with g of x now. So that's in f, you insert the function g instead of x. So the function f of x was, remember, it was 2x plus 4. Now you will take, let me just write it in a different color, you will take this x out, okay? Instead of x, you will insert g. So that becomes, if you insert g in f, I mean, I can write this in this way if you like. It's going to be 2 times g of x plus 4. You can write it in just like the final answer. It's because you know what g is. You know, g of x was square root of x minus 5. So you plug that one for g, it's going to be 2 times square root of x minus 5 plus 4. Sometimes you may get this question of finding the domain of these functions. It's really simple. You look at the combination and you see there's radical, and under the radical you have x plus 5, so x minus 5 should be greater than or equal 0. So x should be greater than or equal 5. So you get the domain of this function to be 5 comma infinity. So this is how you find those combinations. Let's find the other way around. Let's do this with the actual other direction. Let's find let's find g composed with f of x. So that's going to be g of f of x. Now in g, remember what was g of x? That was square root of x minus 5. So now you will take that x out, x is gone, and instead of x you will simply plug in f of x. So that's going to be square root of, we plug in, instead of x we plug in f, which is 2x plus 4. So it's going to be 2x plus 4 minus 5, and you can simplify that to this will simplify that to square root of 2x minus 1. Please keep that in your mind. You need to simplify them every time. Like, you need to simplify them. I can give you, for example, one example, like let's say f is 3x minus 4, then let's say g is x plus, let's say 20. So let's say, for example, you try to find f composed with g of x. So you find f of g of x. So g goes into f. Now that's going to be, you have x plus 20 goes for x in f. So it's going to be 3 times x plus 20 minus 4. See, you need to simplify it. If you multiply, it's going to be 3x plus 60 minus 4. So that's going to be 3x plus 56. So that's how you do the combination. So here's the final example. I put the table for you in there. So the question is this, the first question, find g composed with f of 1. So look for g of f of 1 over the table. So I need to find f of 1. I go to table for f. Here we go, f of 1, which is 4. So I need to find g of 4. G of 4 here, it's 5. So that's the answer. That was like the first problem. Now let's take a look at the second problem. It says find f composed with g of 4. So I'm looking at f of g of 4. Now look at g of 4, I already know that, which is 5. So I'm looking at f of 5. But f of 5 is not given in the table. So that means f of 5 here is undefined. Or you can just say it does not exist. It's the same thing. In the table, we don't have a value for 5. And the last one says find f composed with f of 3. So I'm looking at f of 3. So I look at f of 3. F of 3 is 1. So I plug in 1 in f, and I find f of 1 to be 4. See, you just simply, sorry for that noise, but you just simply plug in that value in f once, and whatever you get in here, like this, whatever value you get in here, this value, 1, then you plug that one into f to get the final answer. So I hope this video is helpful. So thanks for watching. See you next time. Bye.